On to the second central moment. So the second central moment, the motivation behind it, recall from last time, is that we have this expectation in the first central moment of x minus the expectation of x. And the problem is this is averaging our deviations, but our deviations end up zeroing out on the average. So they balance that at a zero value. So what this is telling us to do, the second central moment, is saying we want to capture these deviations. We want to get a sense of, because there's a real sense in which, okay, 1 minus 2.7 deviates negative 1.7 from its mean. So the mean value of this set, the 1 observations, they deviate by negative 1.7. The 2 observations deviate by negative 0.7. And the 5 observations deviate by positive, jumping the gun there, minus 2.7 equals positive 2.3. So in order to retain this deviation, such that these don't cancel out, all we do is square what we have here. So don't let this intimidate you. All it's literally doing, the only thing we've changed is I added a square at the top of that expression of centering. So literally it's just saying, okay, square terms, obtain those values, and because it's an expectation operator, we're going to sum and then multiply by their relative probabilities, just like we have been throughout this series. So this ends up equaling, let's see here, 2.89. This one ends up equaling 0.49. This one ends up equaling 5.29. So then we sum these weighted by their probabilities. So 2.9 multiplied by 0.2 is the probability of those ones. There's 2 observations out of 10 is 0.2. I'm going to assume from here on out you kind of get it, so I'm just going to write these out then. 0.49 multiplied by 0.5 plus 5.29 multiplied by 0.3. This will give us down here 0.578 plus 0.245 plus 1.587, which equals 2.41. Now, what this means, or what this is telling us, this is literally the same thing as the variance of x. So that's all that's going on here with this. If you were to plug all of these into a variance calculator, you will get that value out as the variance of x. Population variance. That's why I made a big how to do about this in the first video, that this is a population. So with that, I'll leave you guys, and then next time we will be talking about the third central moment. I will see you then.